Okay, Ella, here we go. This is what we're going to do on Monday and then a little bit on Tuesday, too. So I want to make sure that you know what you're doing because there are 3 formulas that you need to do this. So let's get started. So first, simple interest. And we have some letters here. I stands for interest. That's like how much money you earn when you have money in a savings account. The P is the principal. That is the amount of money you initially invest or take out as a loan. So the principal, the amount of money you have. The rate is the R. The rate is how much the percentage is. And then T is time, the time that it takes. So I equals P times R times T. I equals PRT. All right? So here's the first example. This is number 11 in the book, which you're not doing, but that's what we'll do it here. $620 is the principal, the rate, 6.25% in 5 years. So that would be 620 times 0.0625 times 5. So you have your principal, your rate, of course, changing that into a number, a decimal instead of a percent. Move that decimal spot 2 places, 0.0625, and then the rate or the time, 5 years. And if you multiply all that out, you get 193.75. So that means that the interest you would earn would be $193.75, or that could be, if you took a loan, that's how much more you would owe. To find out the total amount at the end, like if it is an investment or if it's how much you took out as a loan, you'd add those together, and that would be the total amount, either that you have as the loan or amount that you invested after 5 years. Now, here's an interesting problem with this simple interest thing, because what happens if they don't just give it to you in years, they give it to you in months? So the principal on this one, oh cool, I circled it, okay, whatever. The principal is 2020, the rate is 0.08, right, 8%, and 18 months. So you have to think of this as how many years would this be. So that would be 8 months. Oh goodness, that's 8 out of 12 months. So let's see, 8 over 12, that sounds like 3/4 if you simplify it. So that would be 0.75. So whatever you would have, whenever you have months, is change it into a decimal of some part of a year. So if you'd have 6 months, it would be 0.5. So in this case, it's this. It's 2020 times 0.08 times 1.75. Should be 282.80. Uh-oh. That's not the answer the book has. What did I do wrong? Let's try that again. Maybe I typed something in wrong. 2020 times Of course, you're probably yelling at me right now because I can't do math. 18 months is not 1.75, is it? Because that would be 12 months and then another 6. So that's 1 whole year and half of another year. So I should have done 1.5. Let's try that again. 2020 times 0.08 times 1.5 equals 242.40. So, if you get one of these with months, make sure you do that, and make sure you do it right. Ha ha ha. There you go. All right, now this is the formula for compound interest. Now this is nice because this actually gives you the total amount of the loan or the total amount that you've invested, not just the interest. So that's the nice part of this, is you get to know everything. Some of the things you should notice: the P is the principal, same thing as before. The rate, same thing as before. And the time is the same thing as before. Now with compound interest, what that talks about is that the interest gets added back in, or compounded. That's where the word compounded interest comes from. It gets added back in a certain number of times each year. Sometimes it's once a year, sometimes it's twice a year. So we'll keep that in our minds as we do this. So now let's do an example. We'll do number 17. That's $3,850. The rate is 5.25%, and the time is 2 years. Bad looking S there. Okay. And these are compounded once a year. So we don't know the amount. We're going to get to that. The principal is the $3,850. Now, the 1 plus the rate over the number of years, or the number of times compounded. We said the number of times compounded for this problem is 1. It's compounded once a year. The rate is the 5.25 And we need to change that, of course, into a decimal. 0.0525. Now up here, the number of times a year is once, and it was 2 years. Now there is an easier formula to use if you're only compounding once a year, but we're using the same formula for other ones as the more complicated ones. And the more complicated ones have when the number down here and up here would be different, but we'll get to that. All right. So for now, 3850, and hopefully this makes sense. If you say, this number over 1, that's just this number. And 1 plus this number should look just like this, 1.0525. Which means I basically just took this and added it as a decimal right after that. Hopefully that makes sense to you. And we don't need to do anything with this because it's a 1 right now. Now out here, this is an exponent. These are powers. And it's 1 times 2, which means that's just that squared. Now, you can't do this multiplication until you do that. So the first thing I'm going to do is take 1.0525, and I'm doing x squared. And when I do that, I get 1.1078. And then that's times 3,850. So again, I did this first. I did this square. I just took it 1.0525 times itself and got 1.1078. Alright, now I can do the final multiplication. 1.1078 times 3850. And that final number, and I hope it's the right answer, let's see, 4265.03. See if that's what the book says. 4264.86. They did a little different answer, but then I rounded this off, when I did this. So, but that's pretty close. I mean, that's pretty much the right answer right there. So, that again is when these numbers here are both 1s. All right. The next one I'll show you is similar to that, but it's going to be compounded differently. So we'll show that on the next one. All right, now here is one other compound interest one, except this time the directions on this is number 29 in your book. This one says that it's compounded twice a year, and that's what the n is. This is the number of times per year it's compounded. So that's 2, and it's also doing it for 2 years. So let's see how that looks. So that means we have 975, and then it's 1 plus, and the rate is 0.072, right? 7.2%, 0.072. And then you have to divide that by 2, because it's 2 times a year it's compounded. And then out here we have the 2 times it's compounded times the 2 years. So this is the number of times per year it's compounded, and this is the number of years. Alright, so now let's see what happens here. First thing I have to do is I have to do 0.072 divided by 2. 0.072 divided by 2, that's 0.036, which I can now add to 1, and now get ready to do this. 975 is still there, and I have the 2 times the 2 right out here now, the powers, the exponents, and that's 4. So now in my calculator over here, I put 1.036, and I'm going to do that to the 4th power. And that looks like 1.15, and I'm going to go a little further. 20 times 975. And I did some rounding there, which means it won't be a perfect answer for what the book wants, but, hey, pretty close. So now I'm doing that, and I get an answer of 1123.20. 1123.20 is the final answer. So the things to remember there is number of times compounded each year, twice, and then the number of years. So 2 times 2 is 4. There you go.